Hello students. In the last session we have seen about BLE, Bluetooth Low Energy. In this session we are going to discuss about IEEE 802.15.4 and as well as Wi-Fi. Okay, so let's start with the first one. So this is an important technology because it supports other protocols like ZigBee as well as 6LoWPAN. Okay, so both of these technologies, ZigBee as well as 6LoWPAN, they use IEEE 802.15.4. Okay, so this standard IEEE standard 802.15.4, it focuses mainly on the physical layer functionalities as well as data link layer functionalities in the OSI model, right? Okay, so this standard defines physical and MAC layer functionalities for PAMs, personal area networks, which demand low rate and low cost. Okay, so for example, you are developing an IoT application, let's say health application, where you need to fix or insert or place different sensors near the patient or on the patient, okay, for sensing different phenomena. For that we have to use some kind of technology, and all those sensors need less data rate, that is lower data rate, as well as they have to be lesser cost, okay, low cost devices. For such kind of applications we can use this technology IEEE 802.15.4, which is also called as LR-WPAN, which abbreviates to low rate wireless personal area network. Okay, so the standard is also called as LR-WPAN, low rate wireless personal area network. Okay, right. So this technology offers different advantages. So simple, and it is a simple and flexible protocol stack, less cost to implement it, and it offers low energy consumption, and it operates in a short range just like Bluetooth, and it provides reliability while transferring data, and the operation the operation is easy. Okay, right. So these features, these advantages makes this standard suitable for personal operating space, POS, also called as PAN, personal area network. Okay, right. And some points about this technology. So the devices which use this IEEE 802.15.4, they can have two types of addresses. One is either 16-bit or another one is 64-bit address. Just like you have IP address, these are other kind of addresses, either 16-bit or 64-bit address. And the standard uses an access mode called direct sequence spread spectrum, DSSS, direct sequence spread spectrum. It's a way of accessing the channel, and it operates in three different frequencies: 2450 MHz, or 915 MHz, or 868 MHz. That is based on the channel, 16 channels. This frequency uses 10 channels, and this frequency uses 1 channel. Okay, right. So now comparing against the OSI model, so as I already told you, the standard focuses mainly on the physical layer as well as MAC layer. Okay, so the physical layer, it provides these functionalities, and at MAC layer it provides these functionalities, right? Okay. Uh, so let's talk about these two layers. What are they responsible for? So physical layer, it is responsible for activation and deactivation of the radio transceiver. That is, when to activate the radio for sending the waves, when to deactivate it, that one. And energy detection within the current channel, link quality indication for received packets, clear channel assessment for carrier sense multiple access with collision avoidance. Another responsibility is channel frequency selection, and another one is data transmission and reception, that is sending and receiving the data. Okay, so I told you this technology consumes less amount of power, right? That is, the energy saving aspects are mainly linked to ED, that is energy detection, LQI, that is link quality indication, and CCA, which is clear channel assessment. Okay, so the way this technology does these things, that is energy detection, link quality indication, and clear channel assessment, the way it does these things will will save the energy, that is low power consumption. Okay, right. And coming to the second layer, which is the MAC layer, it provides access to the physical channel through which the data is sent and received for all the upper layers. So upper layers means like application layer. Okay, and it provides two services, the MAC data service and MAC management service. Okay, next, so this standard, the MAC layer standard defines two different methods for accessing the channel. One is beacon enabled mode, which is called in short called BE, and another one is non-beacon enabled mode, NBE. Okay, right. Now let's see the responsibilities of MAC layer. Beacon management, channel access, guaranteed time slots management, frame validation, delivered frame acknowledgement, and last one is association or disassociation activities. So these are the responsibilities of MAC layer. Okay, and coming to the topologies, the standard supports two topologies. One is star topology, another one is peer-to-peer topology. So what happens in a star topology is, so if you look here, there are three types of nodes, right? The green node, the blue node, and the white node, right? So this green node is called PAN coordinator, personal area network coordinator, and this blue node is called full function device, or in short FFD. Okay, and this white node is called reduced function device, or in short called as RFD. So there are three types of nodes. Now let's see. So what does this PAN coordinator do is, or in short we can say coordinator. So in any network topology there is only one PAN coordinator. Okay, in any network topology that uses this IEEE 802.15.4, there is only one coordinator. So what does it do is, it manages the network, that is set up the network, okay, and maintain information about the entire network, maintain the information. Okay, so these are the main things that a coordinator can do. Its primary purpose is to manage the network, which is setting up the network and also maintaining the information about all the other devices which are connected in the network. And coming to this full function devices, it can send data, receive data, okay, and also it can route the data, that is accept the data and forward the data to another device, that is called routing. Okay, and the last one is RFD, reduced function device. This kind of devices can only send and receive data. Okay, send and receive data, but these RFDs cannot route the data. They can only communicate but cannot do routing. It is not supported in RFD. Okay, so now let's look at star topology. So in the previous session where I was talking about BLE, Bluetooth Low Energy, there I talked about the star topology. So then in a star topology there is a central node. Here it is called as coordinator, and with this coordinator the remaining two types of devices can connect, like an FFD or RFD. They can connect with the coordinator. Okay, so for example, this RFD wants to send some data to another RFD. First it has to send the data to the coordinator, and the coordinator sends the data to the second RFD. So this is a typical star topology. All the communication takes place through coordinator. But when you see this peer-to-peer topology, again you will have only one coordinator, but this time the remaining devices may not be connected directly to the coordinator. For example, if you see these four devices here, these RFDs are connected to this FFD. Okay, they are not connected to coordinator. For example, if this RFD wants to communicate with this RFD, it will send the data to the connected FFD, and then the FFD sends to the another RFD. Okay, so whereas this is not the case in the star topology. In the star topology, the data should go to the coordinator, and from the coordinator it goes to the destination. But here in the peer-to-peer topology, it is not a necessity. Okay, so that is this peer-to-peer topology. So that's it about IEEE 802.15.4. I am not showing you the frame formats and all these things. If you are interested in the frame format, how the data is transmitted, you can search in the internet about IEEE 802.15.4 frame format and you can study. Okay, so next we are going to look at Wi-Fi. So we are all familiar with Wi-Fi, right? We use Wi-Fi at homes, shopping malls and everywhere, right? Okay, so this technology, Wi-Fi technology, is standardized by an organization called IEEE, which is a technology for wireless local area network. Okay, so Wi-Fi is a technology, it's a protocol for wireless local area network, and this technology has evolved over the time because of specific demands. Okay, specific need. So what are those needs? They are typically like large range of operation as well as higher data rates. That is, the speed of the data should be high. Those are the demands, the need, and that evolution has led to different standards, Wi-Fi standards, and all those standards are merged into a single term called wireless fidelity, Wi-Fi. Okay, and there is another group called Wi-Fi Alliance, which looks after different Wi-Fi products. It certifies different Wi-Fi products. So if some company is going to sell a Wi-Fi product, it has to get the certificate from this group, Wi-Fi Alliance. Okay, right. So I told you that Wi-Fi has evolved over time. So these are the different wireless standards, 802.11 standards. So you have A, B, G, N, A, C, and we will also talk about another standard called AH. Okay, which is developed specifically for IoT. Okay, so you can pause the video here and look at this table. Okay, so before this standard 802.11a, there is the first standard, which is 802.11. Okay, after that we have this 802.11a, so which was adopted in the year 99, and B is also adopted in the year 99. So in the same year we got two different versions of 802.11, and G was adopted in 2003, N in 2009, and AC in 2014. And you can see the corresponding frequencies and data rate, maximum data rate. So this 802.11 AC offers 1 Gbps speed, very fast, and indoor range as well as outdoor range. Okay, so based on the Wi-Fi standard, whichever devices are communicating with each other, those things are called as stations, or in short STAs. Okay, the devices which are communicating with each other using Wi-Fi are called stations, and the communication is direct. The communication takes place directly between these two devices. Okay, forming an ad hoc topology. So ad hoc means the network is created as and when needed. So when you want to communicate, the network is created. After that, the network is broken. Okay, there is no network. Such kind of topology is called ad hoc topology. The network is created on the fly. Okay. So like in the previous protocol, that is IEEE 802.15.4, we have seen the star topology. Here also we have this star topology, and this topology is created on the fly when a particular station acts as a concentration point for other stations. Okay, and that concentration point, that device which acts as a concentration point, becomes access point. So typically this access point is wireless router. Okay. So here STAAP means access point, the station which is acting as access point. Okay, and this access point defines a coverage area which is called basic service area. Okay, and what does this basic service area provide? It allows different stations to connect with the access point, and those group of devices is called basic service set. Okay, it's very simple. For example, this is access point, and we can connect different stations to this access point. Stations means devices, mobile phones, laptops, desktops, or whatever, and this access point is the router. So now if you see this is a star topology, right? Okay, so this access point, let's say it covers this area. I am, by area I mean geographical area, okay, physical. So such area will be called BSA. Okay, basic service area, and this group of devices is called basic service set. That's all, very simple. Okay, and the access point, which is the router, is usually connected to the internet. Okay, so from a mobile, if you are connected to the router will transmit the data to internet. That is how the Wi-Fi works at the home or office or anywhere. Okay, right. Uh, so this IEEE, the organization IEEE, it focuses on defining physical and MAC layers for this standard, that is Wi-Fi standard. Whereas the Wi-Fi Alliance group, it aims to work with only physical layer, not both the physical and MAC layers, only the physical layer. Okay, so as I told you, this standard was first released in 1997. After that, we have the IEEE 802.11a and b in the year 1999. Okay, so the Wi-Fi physical layer, that is IEEE 802.11, so it has evolved from the frequency 2.4 GHz to 5 GHz frequency, and this is a term multiple transmission beamforming technology. It's a type of transmission technology, multiple transmission beamforming technology. It improves the transmission as well as reception of data. So that is how we achieve this data transmission rate of 2 Mbps, which is in 802.11, to 600 Mbps, which is in IEEE 802.11 EM. Okay, and further in IEEE 802.11 AC, you have seen in the table, no? The speed is 1 Gbps. Okay, right. And at the MAC layer, we will have something called access method, medium access method. So for that, this Wi-Fi standard uses carrier sense multiple access with collision avoidance, or in short called as CISMA-CA. Carrier sense multiple access with collision avoidance. It is a technique or a method for accessing the channel or medium. Okay, don't worry about the details, just remember these things. And the MAC layer functionalities like acknowledgements, fragmentation and reassembly of frames, interframe gaps, and exponential backoff algorithm, roaming, security and power saving mechanisms. These things are adopted by this Wi-Fi technology. Okay, now we are going to enter into the discussion about 802.11 AH. Okay, so this is like a preface to 802.11 AH. Why they developed this new version of Wi-Fi. So see here. So in the olden days, when Wi-Fi is developed, it is for communication between computing devices or computers or mobile phones. So the end devices here for Wi-Fi standard is computers or laptops, desktops or mobile devices. Okay. So later this thing came into picture, which is machine to machine communications, like the things which happens in IoT. Okay, the devices have to communicate with each other. No human beings are needed, right? For IoT. Okay, that is called machine to machine communication. So these things are coming into picture, and this machine to machine communication demands or needs different characteristics. Like one is transmission range should be above 1 kilometer. 1 kilometer means it's a large distance, significant distance, and transmission rates must be higher than 100 kbps. Okay, that means data rate should be high, but the devices should consume low power because they are battery operated most of the time, and it should consume low power. Okay. So the network should support large number of nodes, but the amount of power consumed should be low. For such thing, the IEEE has come up with this new standard, which is 802.11 AH. Okay, and they have proposed some improvements in the physical layer and MAC layer. Okay, right. So based on those improvements, the new technology, which is IEEE 802.11 AH, it can be used not only as wireless sensor network, but also can be used as backhaul infrastructure. Why? Because this supports larger distances. Okay, and sensors can be connected to the data aggregators or data collectors. Okay, so you can see here the reason is why it can act as backhaul infrastructure is the coverage area is large. Okay, and data rates are also huge. It's faster. Okay, so this was developed for solving the limitations of the previous Wi-Fi standards A, B, G and N. Okay, so this was specifically developed for machine to machine communications, which is nothing but IoT. So I am not saying M2M is a synonym for IoT, but M2M, machine to machine, is actually a part of IoT. So IoT is not only about machine to machine communication, it is a lot more. So machine to machine communication is only a part of IoT, right? Okay. So in the standard, the devices which are connected to the access point, so as I already told you, the access point is a router. So the router is connected to different devices like mobiles, sensors, whatever it is, So they need to maintain connection and they need to be synchronized with this access point, okay, at all times. Even then, the energy consumed by the devices is less in IEEE 802.11 AH. So it's a good thing, right? So when a device is maintaining connection and is being synchronized with the access point, that means the device is always turned on. Okay, even though it is always turned on, this technology consumes less power. Okay, which is suitable for IoT. Right. So finally, this new technology IEEE 802.11AH, it offers long range as well as low power consumption when compared to other wireless local area network technologies. So what are the different other wireless local area network technologies? Wireless LAN technologies. You have Bluetooth, right? We have seen these things in the previous session. We have BLE, Bluetooth low energy. Just now previously we have seen this LR-WPAN, low rate wireless personal area network. Okay, right. So that's it for today. So let me recap what we have seen today. So we have started with this IEEE 802.15.4. It is used by other technologies like Zigbee and 6LoWPAN, which we will discuss in the next session. And this focuses on two layers, physical layer and data link layer, and it is also called as LR-WPAN. So these are the advantages and some points about this. Comparison against OSI reference model, physical layer responsibilities, MAC layer responsibilities, and finally the topology supported by this technology, star topology as well as peer-to-peer topology. And then we have discussed about Wi-Fi, standardized by IEEE, and the standard number is 802.11. So Wi-Fi abbreviated to wireless fidelity. And we have seen this table which contains different wireless standards, 802.11 standards. And then we have seen some important points like devices are called as stations, and the device which acts as a center point is called as access point. Okay, so the transmission technology. Then we have focused on machine-to-machine communications. What are the distinct characteristics that is needed by machine-to-machine communication? And then finally we touched upon the new Wi-Fi technology, which is IEEE 802.11 AH. So it is the best suitable for machine-to-machine communication, which typically happens in IoT. Okay, and in the next session we are going to look at 6LoWPAN. So that's it for this session. Thank you.